We have this, close your eyes. Some of you don't want to see it, so. All right. Today we're working with codes. And I know that you did a little bit with codes in English class at the beginning of the year. And I know you did a little bit with codes in social studies class with Mr. D'Amico last year. So we're going to use some of those concepts because codes are actually very mathematical. And codes are a great introduction to the topic that we're starting to work with now. Okay. So we have Ashley, Jack, and Omar, and they each created a secret code. But we need to figure out what their messages are and if they work. Okay. So we're going to take a few minutes here. And we can break it up into groups. So let's have one section of the room figure out Ashley's code. We'll have the middle section, this group here, figure out Omar's code. And then we'll have this side of the room figure out Jack's code. Okay, so let's talk about what their codes are very quickly before we find. Ashley's code is here. Okay. You can see she has an arrow from one letter to the next. Oh, not what I meant to do. So this is Ashley's code here. Okay. Omar's code actually requires like the numbers and the rows. So the key here is that 36, the first digit of 3, the second digit of 6, 36 is R. Okay. So if you had something like 45, 45 would be here, 4 and 5 where they meet. Okay. And then Jack's code, he rotated the letters of the alphabet. So so he wrote A equals B, B equals C, and so on. The key here is that at the end, Z equals A. Right, so he did that. Okay. So those are their codes. This is Ashley's message. This is Omar's message. And this is Jack's message. So let's take 3 minutes. 3 minutes where you are, and you all have one code to decipher each break. Try to figure out the code. So Ashley, you two are Omar. Your table's Omar. Jack.
She said it first. She said Jeff. I mean, Jeff. You're thinking.
He is. I told her that earlier.
I don't have it. I think I'll have it. How dare you?
You still want me to go?
I get it.
And after S T, and then do space, space next word. That's K, W, R, and
Well, safety.
If you finish your code fast, try a different one. See if you can find any issues with any of the codes, or if they're perfect the way they are. And you've created codes before, so you have a little bit of experience with what makes a good code and what makes a bad code.
Jack's code starts with Q, J, O, F, S, T.
Q, yes.
I can't see Kimberly.
Almost the 8 supposed to be there. With the I.
It's NBUI. NBUI. Something's wrong with Jackson. Something's wrong with the code.
Why are you
Yeah,
writing it
something's
all
wrong.
on?
Okay,
Okay, so let's take a look at each code that's here. Let's first look at Ashley's. What did we get for Ashley's code? Good, yeah. Kinder, KINERSLOVEMATH. How about Jack's code?
It's so hot in here, miss.
Oh,
Miners.
KINERS.
And then I didn't mention.
It's the same. Okay, the same thing. Love, math. I know. You're thinking I'm super creative.
Oh my god.
What's up with Omar's code?
He's wrong.
I don't know. What's going on? Everybody look at Omar's code. What's Omar's? Let's go through the
He
list.
has numbers.
29. What do we got?
Hi.
29.
E. 29 is a P. 17. HI. What's the issue with his code?
One of those.
What
I.
letter is it for 17?
I.
Are you sure?
Yes. I and H.
But what if he was spelling a code about fish food, the really good Ben and Jerry's ice cream that's spelled like that? How do you know it's an I and not an H?
Because we know the rest of the letter.
So you're generalizing because you feel like you know the code, but what's the problem?
K.
Yeah, H and I are together, which means you really know what the code is supposed to be.
No.
No, this is your issue. Okay, so we know that in a code, the value you get out depends on what you put in. Ashley's was very straightforward. I knew that if I saw an A, that I was always going to get the same letter out, like a different letter out, right? I knew with Jack's that if I saw the letter A, it was going to mean a B. But Omar's was a little bit wrong because the number 17, I didn't know what I was going to get out. Okay? If you have a code that you created or that you took from somebody, will you always have just like one result for each part of the code? Should you? If someone had you break a code, should you clearly be able to figure out each part of it? Yeah, right. That's really what the cipher is. Okay, so Ashley's. If I wanted to go through Ashley's here, I know that I can match it out. N is an M, Z is an A. This is very clearly math is fun. And I'm good. Don't laugh when I say math is fun.
What is this?
Math is very fun.
Fun.
In reverse, it works as well. If I had great job, I could create T and an I and a B. I can go the whole way, right? Her code is very clear, meaning one letter is always giving me one letter. Jack's code is the same thing, right? I know that an I equals H, F equals E, M is L, the other M is L, and because I know that every letter is going to give me an answer.
That's Jack.
So there's something wrong with Jack's code for the thingy. So instead of love, it says job with a J.
We're off by a letter.
Yeah.
Did I create it incorrectly? The other class got love. But maybe they
it's
just
supposed-
stopped because they assumed.
Yeah, probably because the letter before it's supposed to equal the letter after.
So that was my fault. Not the code. That would have been my fault.
Job.
Yeah, it is.
Jack's code in reverse works as well. I'm going to take a look at that one for the original activity. I can create the code for awesome. I can go backwards. Here's the issue.
What?
Omar's is a problem. I know 38,
Omar's
Is
the
it
cool
T?
guy.
and I know that 09 is an E. But what's 17? Is it H or is it an I?
It's H.
Are you sure?
Well,
What if the code is tie rack?
What?
Do we know? A tie rack, like you hang your ties on it. We don't know, and this is the problem. Okay. We're skipping this to
big.
this. A function. This definition. We're going to write this definition down. These two.
Oh my
It's a little bit more than we would normally write, but these are important terms. A function is a rule that relates each input value to exactly one output value and can be represented in a variety of forms. So all of these codes are functions, sort of. And that second section, examining input-output pairs from equivalent forms, such as tables, mappings, and ordered pairs, helps to reveal whether a relation is a function. So the unit that we're working in now is all about functions. But the first thing we need to do before we dive into our work with functions is learn how to identify if a relationship is a function or not. So the three codes that we looked at, we need to identify if they're all functions or not functions. And the key definition here of a function is that each input, everything I put in, gives me exactly one output. Now, when you finish writing, think about Ashley's code, Jack's code, and Omar's code. Think about the inputs for the code, the letters that you were given, and the cipher, right? How to break it. Based on what you know about a function, that every input gives us exactly one output, could you tell me if Ashley's code, Jack's code, and Omar's code are functions or not?
This English, miss?
I know we don't write often. Not like this much.
If they made a DC name, would you go? Well, no?
Does anyone need more time writing these two sentences?
I do.
Okay. For those of you who did finish writing,
Yes.
think about the code that you broke. Is that a function or not? Once you figure out yours, think about all three of them. Ashley's code, Jack's code, and Omar's code. Do all three of them represent functions? Do any of them represent functions?
Sounds muffled.
Miss, why is it so
Are we
hot in
okay
here?
to slide over?
Yeah. Slide.
Is there at least someone near you that has it, so if you need to finish writing it?
We're supposed to write the bottom part.
Slide. Slide.
If you don't have it finished, someone around you does. Okay, so we'll make sure that we finish all of it. You'll have time. Okay, because we're going to do a couple practice problems in a few minutes. So now we need to determine if each relationship represents a function. Ashley's code. Is that a function? Why yes? Who can explain, based on the definition of a function which you wrote down, how do we know that Ashley's code is a function?
Like, okay, well, everything, like, it gives out exactly one output value. And then, like, it can be represented in multiple forms because you can go backwards. Like, if they give you a word, you can turn it into code and stuff like that.
Yeah, every letter of her code gives me one letter result, right? An input of like an A will always give me a Z. An input of an E will always give me a V. So I'll know one input will always give me one output. So hers is a function. How about Jack's? He rotated the letters in the alphabet, and he broke the whole thing out in a table on that previous slide. Is his code a function? It is. Why?
You can turn it to be represented in a very rare team.
Oh, okay. So we could have represented it in multiple ways. But think about if you got that code. Say he put it down in front of you and he said, solve this code. Here's the cipher, and here's the code that I want you to scramble. Would you have been able to figure out, because everyone had exactly one letter, what the code was? Yes. How about Omar's code? Why is Omar's code not a function? Because of the number 17. Absolutely. The number 17 has two outputs. It could be either an H or an I, and that's a problem. That is not a function. Now, the majority of the work that we do in this grade level is working with functions. The first thing we do is identify if something is or isn't, right, which is why we're spending today and a little bit of tomorrow doing that. You will see this topic on the PARCC exam. And we don't really spend a lot of time just saying we're practicing the part. But the reason this gets so frustrating, we spend a lot of time working with functions. Starting on Monday, we'll be grabbing them, comparing them, we'll be using real-world scenarios, and then what's going to happen is you'll see a question on the PARCC exam that says, look at these Venn diagrams, which one is a function, which one is not a function? And all of a sudden, we go back to having to identify what even makes this relationship a function. Because we've been working with them for so long, we're just so used to them. So these are 4 different examples. Number 1 is a sentence. Number 2 is a Venn diagram. Number 3 is an order of ordered pairs, the X value, the Y value. And then the last one here is a graph. Okay? I'm actually going to pause the video here because we're going to spend a little bit of time on this slide, and I'm going to put probably a picture of this slide once we're done writing all over it up on the Google Classroom after class. So let me pause very quickly.